want to learn new data skills. Because your job, but you don't have time to learn new data skills because your job. With Data Camp, you can learn.
Let's start with this problem. Find the mean, median, mode, and range of the following data set. Now the first thing that I would recommend doing is arranging the numbers in increasing order. So the lowest number is 7. So what is statistics? Statistics is basically the science of collecting, analyzing, and interpreting data, even presented it as well. And statistics can be broken down into 2 categories. On the left we have descriptive statistics, and on the right, inferential.
Statistics. It's just science. Mixing. Analyzing. Statistics.
Hey Priya, we are almost halfway into 2024. Do you still think there's enough time for me to start a career in business analytics or?
Statistics. Right. They just come to the script. It just stops the script. This is the main.
In this video, there's popular difference and it's up 100. We do a lot of work statistic parameters. What else? Population. The energy is, and the parameter, the population portion is simply P. Finally, we have the sample size. Well, let me just say the size. The size of the sample is represented by the symbol lowercase n. So that would be a statistic. The size of the population is represented by the symbol capital F. What would you?
इंटरनेट भी नहीं है तुम्हारे क्यूबा में। हम एक्चुअली देखते हैं नॉर्मल कपल्स की तरह।
जज्बाती है दिल।
अरे अफेयर किसके साथ होगा? मेरी बीवी के साथ।
चल रहा है क्या?
I see you're interested in learning about Postgres. Why not learn from me, Dr. Chuck? I'm a professor.
Let's just skip to the first game.
Initial rank. You could say that in a race, the person who got first, you can't really measure the difference factor. It's the index. Time of day, if we degrees by 30 Celsius. If you're dealing with back to number 1, use in because 50 meaning, and divided by 30, we get 3. And so we could say that this student has a, and that would make sense. We can see that the ratios, they're meaningful. And the last thing is true. It does contain a 0 start. Since of heat. Good and good. So this can be to Fahrenheit different. That's it. And 90. You can read Fahrenheit. It doesn't. There's no true one. The order matters because you can place these temperature values in order. 30 is lower than 60, and 60 is lower than 90. Hence, 56 minus 30 is 26, and 70 minus 56, that's 14. So as we can see, the differences are measurable, and we could also measure the ratios. If we take 90 and divide it by 30, we get 3. And so we could say that this student has a grade that is 3 times higher than this student with the lowest test score. And that would make sense. We can see that the ratios, they're meaningful. And the last thing is true. It does contain a 0 starting point. Let's say if we have another student who didn't answer any questions, he would have a grade of 0. So that means that either he didn't do the test or the square root of 250. So 7.
Are you a student who learns from YouTube videos or attends online classes? Video Notebook will make your life easier. When you're watching tutorial videos on YouTube before your exams, you can use Video Notebook to take text notes and screenshots on the videos you watch. They link back to the point in the video when you took them, so you'll no longer need to watch the entire video over again. Even better,
Turn. Well, we should probably use a different letter than A. In this video, we're going to talk about how to calculate things such as you take the reciprocal of the data 7 divided by 2 and 20. Today, we're going to talk about, and I just want to put Today, we're going to talk about the arithmetic mean, the geometric, in addition to all the sequence. Have to add 3. Dealing with needs to come for 1 and 1 in A5 is A3. 8 times finding so 7th power. Got the 4th term because that's the middle term. Likewise, taking the geometric mean of all 7 terms in the geometric sequence gave us the middle term of that sequence, which is the 4th term. So I want you to see how...
You know, if you practice speaking in English for 20-25 minutes every day, you can really improve your fluency and confidence. Yes, it's absolutely true. All you need is someone who's really good at English and is willing to help you practice by speaking to you every single day.
So the weighted average is going to be the sum for W. I'm going to calculate the middle term in a geometric sequence. Well, it turns out that it works the same way with the harmonic mean formula. You could use that formula to calculate the middle term in a harmonic frequency. So let's say if we have the sequence 1 over 2, 1 over 5, 1 over 8, and so forth. Now, notice that the denominators of these fractions, if you just look at the numbers 2, 5, 8, 11, 14, 17, they form an arithmetic sequence. But once you take the reciprocal of the sequence or formula, and is 2 times 5, we can cross out a 2, and we get 1 over 5. And as we can see, 1 over 5 is the value of H2. So, a harmonic sequence. 1 divided by 1 over 5 is the entire west. So this would plus 50 equivalent. Second part in this number plus 12 squared plus 16 squared plus 21 squared. That's 930. 930 divided by 5 is 186. And the square root of 186 is 13.638. So this is the root mean square of these 5 x values. So that's how you can apply the formula. Now let's say if we want to find the root mean square of just 2 numbers. So let's say we just have these 2. Let's say x1 is a, this would be a squared, and x2 is b, that would be b squared, so a squared plus b squared. If we have 2 numbers, n is going to be 2. So we get this formula for the root mean square of 2 numbers. It's a squared.
आपको चाहे पाइथन सीखना हो या फिर Django सीखना हो या फिर जावास्क्रिप्ट सीखना हो, रिएक्ट सीखना हो या फिर बैकएंड डेवलपमेंट, नेक्स्ट.जेएस या फिर आपको इंडस्ट्री लेवल प्रोजेक्ट्स बनाने हो, सब कुछ अवेलेबल है चाय और कोड यूट्यूब चैनल पे। हाँ जी, पूरा इंडिया यहीं से सीख।
In this video, we're going to talk about how to calculate things such as the mean, the median, the mode, the standard deviation, the range, and the variance given a bunch of numbers. So here we have these 10 numbers, 15, 27, 74, 36, 8, and so forth. So how can we find the mean, median, mode using Excel? Well, first, let's begin by finding the total. So we could use the sum function to get the total. And we could just highlight basically that column of data. And this will give us the sum, which is 349. Now, to calculate the mean, you can't use mean because that's not a function for Excel. Calculate the mean. Oh, it's going in different cells. There's 5 numbers. That we have the first 5 numbers on the left and the first 5 numbers on the right. If we follow this pattern, it is clear that the middle number is. So in this video, what we're going to do is make a side-by-side stem and leaf plot. So we're given the ages of males, nuclear 3, 5. In this video, we're going to talk about how to make a histogram. And so what we have here is the test scores of many students in the class. How can we use this information to construct a histogram? Well, the first thing we need to do is create a frequency distribution table. So we're going to have 2 columns. The first one is we're going to.
And we're back in third quarter planning. Adams is quarterbacking this.
In this video, income. So the income is to include the stop here. Then the 80 our highest minute go up by 30K. Difference between 80 point that for your lowest event. I do have D6 is the 60th and so forth. So D9 will be the 90th percentile. So now you can visually see how quartiles, deciles, and percentiles divide the data into different equal parts. Now, what is the meaning of a percent? In this video, we're going to talk about quartiles, deciles, and percentiles. So what are they exactly? Quartiles divides the data into 4 equal parts. What I like (11, 14, 17). They form an arithmetic sequence. But once you take In this video, we're going to talk about quartiles, deciles, and percentiles. So what are they exactly? Quartiles divides the data into 4 equal parts. What I like to think about is quarters. 4 quarters adds up to $1. Now let's draw a number line. And we're going to go from 0 to 100. But let's divide the number line into 4 equal parts. So this is the first part, the second, third, and the fourth part. This is Q1, this is Q2, and here we have Q3, or the third quartile. On the left, this is the 0th percentile. The first quartile is the 25th percentile. The second quartile is the 50th percentile. And the third quartile is the 75th percentile. And this goes up to 100. Percentiles divides the data into 100 equal parts. Think of percentage. 100% represents the total of everything. Q2 is basically the median of the entire data. Q1 is the median of the lower half of the data. And Q3 is the median of the upper half of the data. Now let's talk about deciles. Deciles divide the data into 10 equal parts. Think of a decimeter. A decimeter is basically 1/10 of a meter, which means that it takes 10 decimeters to equal 1 meter. So when you hear the word deci, think of a tenth. So a decile is basically 1/10 of the data. So it takes 10 deciles to cover the entire data. So let's break up this data into 10 equal parts. So this is going to be D1, this is D0, D2, D3 is the third decile, D4 the fourth decile. Fourth decile. Now Q2 is the same as D5, and this is D6, D7, D8, D9, D10. So what you need to know, for instance, is D4 represents the 40th percentile. In this example, D5 is the 50th percentile, represents the 40th percentile. In this example, D5 is the 50th percentile, which is the same as the second quartile. So we can write the percentage values here. So D1 is the 10th percentile, D2 is the 20th percentile, D3 is the 30th, D4 is the 40th, D6 is the 60th, and so forth. So D9 will be the 90th percentile. So now you can visually see how quartiles, deciles, and percentiles divide the data into different equal parts. Now, what is the meaning of a percentile? Percentile. Have you thought about that? The 70th percentile, for example, is a data point where 70% of the entire data is less than or equal to the data point. Now, it can also mean that 30% of the data is greater than or equal to the data point. So what do we mean? Let's use a visual example. So this would be 0, this would be 70, and this would be 100. So let's say if you took the SAT exam and your score ranks among the 70th percentile. So your score is right here. Now, 70% of students had a score that is equal to or less than your score. So basically, you scored better than 70% of the students who took the SAT at that time. However, 30% of the students who took the SAT did equal to or better than you did on the exam. And so that's what the 70th percentile tells you. It tells you that 70% of the data is less than the 70th percentile, but 30% of the data is greater than the 70th percentile, or it could be equal to it as well. So now you know the meaning behind a percentile.
3 crore. Yes, 3 crore is the average salary of a prompt engineer working in the US. So who is a
Now let's say if we have the numbers 2, 3, 5, 7, 8, 10, 11, 13, 15, 16, and 19. How can we find the 3 quartiles in this list of numbers? So what is the first, second, and third quartile? The best thing to do is to find the second quartile first. The second quartile is basically the median of the entire data set. And so let's find a middle number. We can eliminate the first 2 and then the last 2 until we get the number in the middle, which in this case is 10. So I'm going to get rid of the 10. I'm going to separate the data into 2 equal parts. I'm going to put the 10 right here. So 10 is our Q2 value. That is the median of the entire data set. Q1 is the median of the lower half of the data set. So Q1 is 5. As you can see, 5 is the middle number of these 5 numbers. Now what about Q3? Q3 is the median of the upper half of the data set. So the middle number is 15. So that is the third quartile. Now it turns out that there's another way in which we can calculate Q1, Q2, and Q3 using percentiles. Keep in mind, Q1 is basically the value of the 25th percentile. To find the location of a percentile, it's equal to k divided by 100 times n plus 1. So n is basically the number of data items in your list, or the number of numbers in the set. K is basically the subscript. So if you want to find the 25th percentile, k is 25. So let's illustrate this with an example. So let's find the location of the 25th percentile. So it's going to be 25 divided by 100. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers in the list. So n is 11. So let's get the answer. What is 25 over 100? 100 divided by 25 is 4. So 25 divided by 100 is 1/4. And 11 plus 1 is 12. So we have 12 divided by 4, which is 3. So what does this number tell us? The 3 indicates that the first quartile is in the third position. It's the third item from the left. So this is the first item, this is the second item, this is the third item. So the third number from the left is 5, which is our first quartile, as we can see here. And so that's how you're supposed to use the formula. Now let's try another example. Let's calculate the second quartile. So the second quartile is basically the 50th percentile, which we know to be 10. So let's determine the location of the 50th percentile. So it's k divided by 100, or 50 divided by 100. And so that is the second quartile. If you wish to calculate the third quartile, it's basically the 75th percentile, which we know to be 15. So using the same formula, we're going to calculate the location of the 75th percentile. So it's 75 over 100 times 11 plus 1. 75 over 100, if you divide both numbers by 25, you can reduce it to 3 over 4. Now, 12 divided by 4 is 3, times the 3 on top, that gives us 9. So 3/4 of 12 is 9. So the ninth data point, in this case, is going to be 15, which is the third quartile. Let's try another example. So this time we have an even number of items in this list. So let's determine the first, second, and the third quartile. So let's split the data into 2 equal parts. So here we have 8 numbers on the left and 8 numbers on the right. So this time, the median is going to be the average of 15 and 16. If we add those 2 numbers and then divide by 2, this will give us the midpoint, or the average of those 2 numbers. Which is 15.5. So that is our second quartile. Now, to find the first quartile, we need to find the middle number of the numbers on the left. Now they're even, so we're going to split it here, so that we have 4 on the left, 4 on the right. So the median is going to be the average of 9 and 11 is the first quartile. And so the middle of them, calculate and locate in which 5th percentile. So it's k divided by 100, in which case k is 25, and there's 16 numbers and it's 17. Now, 17 divided by 4, that is not going to give us a whole number. In fact, we're going to get a decimal number. So what is the 4.25 value? Well, that's hard to tell. When you get a situation like this, you need to round up and down. You need to look at the 4th value and the 5th value. So this is the 1st, 2nd, 3rd, 4th, 5th value. The 4th value is 9 and the 5th value is 11. So if you average 4 and 5, it will give you 10. I mean, if you average 9 and 11, it will give you 10. And so this is the location. Well, the location of the 25th percentile is this number, but the value of the 25th percentile is 10, which is Q1. So that's how you could use this formula to help get you this answer. Now let's use the same process to calculate Q3. So Q3 is the 75th percentile, which has a value of 19.5. So let's determine the location of the 75th percentile. So it's 75 divided by 100 times 16 plus 1. So it's 3/4 of 17. 17 times 3 divided by 4 is 12.7 feet. So this list of numbers. Let's say if we want to calculate the value of the 6th decile, how can we do so? The 6th The 6th decile is based on the quantums of, we can see a 60 point between the 60th percentile based on the data that we have, 16.5. So this is the 60th percentile based on the data that we have here. That is, of course, if we follow the same process as we've been doing. However, I'm inclined to think that the 60th percentile is based on the 10th value in the list. Well, for one thing, 10 is very close to 10.2. And the 10th value in the list is 16. And here's why I'm inclined to think about it intuitively. The second quartile is the 50th percentile. The third quartile, the 10th. So this is the 10th value. The 10th value in the list is 16. And here's why I'm inclined to think about it intuitively. The second quartile is the 50th percentile. The third quartile is the 75th percentile. So it's clear to see that our answer should be somewhere in this region. So 16.5 is not a bad estimate. However, if we split this in the middle, the midpoint between 50 and 75, if you add them up and divide by 2, that should give you 62.5. And 60 is to the left of 62.5, which puts it more closer to 16 than to 17. Now granted, the calculations will not be perfect because n is small, but as you increase your n value, as you increase the number of numbers in a list, these calculations become more accurate. So keep that in mind. Now there's something else that we can do with this list of numbers. So far, we talked about finding the value of a percentile. For instance, the value of the 50th percentile is 15.5. But what if we're given the value? How can we find a percentile that corresponds to that value? So let's use 12 for example. Now we know that that 12 is between the 25th percentile and the 50th percentile. Would you say this is the 30th percentile, the 40th percentile, the 35th percentile? What would you say? Well, if we're going to ballpark it, the average between 25 and 50 is 37.5. So it makes sense that 12 is between the 25th percentile and the 37.5 percentile. But let's see if we can do some math to get the answer. To find it, you could use this formula. It's x plus 0.5y divided by n times 100. So what is x? In this formula, x is the number of numbers that is less than 12. So all these numbers are less than 12. So there's 5 numbers less than 12. Thus x is 5. Y is the number of times this number appears. There's only one 12, so y is going to be 1. If there were 2 12s, y would be 2. Now, n is the number of numbers in the list. We know we have a total of 16 numbers. We got 4 in each quadrant. And then we're going to multiply everything by 100. So this is basically 5.5 divided by 16 times 100. 5.5 divided by 16 is 0.34375. So times 100, this is 34.375. Now let's round it to the nearest whole number. So therefore, we can say that the 34th percentile is equal to 12. Or we can say that 12 is the 34th percentile. And thus that is how we can find it. And it makes sense because 34 is between 25 and 37.5. So that's a good approximation. Let's try another example. What about the number 16, the 9th data point in the list? what is the percentile that corresponds to that number? Now we know it's going to be between 50 and 62.5. But feel free to pause the video and calculate the answer. There's no need for me to retype that formula. So P of what subscript number is equal to the first 16 that we see? Well, first let's determine X. X is the number of items that is less than this 16 value. So notice that we have 8 numbers to the left of this number. So the X value is 8. Now Y is the number of times 16 appears, because 16 is the number that we're focused on. And that is the ability to make a cumulative relative frequency table and then to use it in order to calculate percentile values. So let's work on this example. Let's create a cumulative relative frequency table, and then let's calculate the 4th, the 7th, the 3rd, and the 6th decile in that order. So to make a cumulative relative frequency table, we need 4 columns. The first one will contain the value, the second will be the frequency, the third will be the relative frequency, and the 4th column will contain the cumulative and relative frequency values. So the lowest value in this list is 2. Now how many times does 2 appear? 1, 2 times. So the frequency is 2. Now the next highest value is a 3. 20. So this tells us that is to calculate the relative frequency. To do this, 2 divided by, that's 0.85. The 50th percentile, notice that 0.4 is somewhere between 0.3 and 0.45. So here is a question for you. Will the 40th percentile be equal to 3? Or will it be equal to 4? Or will it be equal to the average of 3 and 4? Which one of these 3 options is correct? Now, you need to understand that the 30th percentile, it ends with the last 3 out of the 4 3s that we have here, and it begins with the first 4 out of the 3 4s that we have here. So if you want to find the 30th percentile exactly, it's really the average of 3 and 4. However, if you want to find a percentile that is between 2 cumulative relative frequency values, it's going to be the higher of the 2 numbers. 4 is between a percentile of 30 and 45. The value 6 is between a percentile of 0.45 and 0.55, or 45 and 55. So the 9th value, or the value of 9, is between the 60th percentile and the 85th percentile. But if you want to find, let's say, the 85th percentile, it is the average of 9 and 10. And I'm going to explain why, visually, so you can see it. So because the 40th percentile is between these 2 numbers, it's going to be 4. The 30th percentile ends with 3, but it begins with 4. So the 40th percentile has to equal 4. Now what about the 7th decile, or the 70th percentile? What is the value that corresponds to that? So the 70th percentile has a cumulative relative frequency of 0.7, which is between 0.60 and 0.85. Now keep in mind, the 60th percentile ends with 7 and begins with 9. So the 70th percentile has to be one of the 5 9s that we have here. So it's going to equal 9. Now what about the 3rd decile? So that's the 30th percentile. Notice that we do have an exact value here, a cumulative relative frequency of 0.30. So 0.3, or the 30th percentile, it ends with the last 3 and it begins with the first 4. So in this case, it's going to be the average of those 2 numbers. So the 30th percentile will be 3.5. Now what about the 6th decile, or the 60th percentile? Notice that we have that exact number in our chart, or in our table. So thus it's going to be the average of these 2. The 60th percentile ends with the last 7 and starts with the first 5. So the average of 7 and 9 I meant to say it ends with the last 7 but starts with the first 9. So that's the average of those two numbers. That's going to be 8. Now let's confirm these answers. Let's see if we can make sense of it. So we said that the 4th decile is 4. The 7th decile is 9. The 3rd decile is 3.5. And the 6th decile is 8. Now let's go ahead and put this list in increasing order. You could also use the cumulative relative frequency table that we had to do this as well. So if you go back to it, we said that we had 2 2s, and we had 4 3s, and we had 2 6s. We had a 7, and we have 5 9s. And then we have 2 10s, and we have 1 12. Looks like I'm missing something. I'm missing the 4s. So let's go back. There were 3 4s. And then we had 2 6s. 1 7. And then 5 9s. And then there were 2 10s. And 12. So notice that I'm moving everything in pairs. Because I have 20 numbers, and I want to divide it into 10 equal parts, so you can see what the deciles are. So this is going to be the first decile, this is the 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10. And we can say this is 0. So let's start with the 4th decile, which we said was 4. So here's D4. Notice to the left is a 4, and to the right, it's a 4. So the 4th decile, or the 40th percentile, is 4. So because they were the same, we didn't really have to average any numbers. Now, let's talk about the 7th decile. So here's the 7th decile. To the left, we have a 9. To the right, we had a 9. So
what if this was the last paycheck that you are going to get? Within a job or in business, what if?
In this lesson, we're going to talk about how to find the interquartile range, as well as the presence of any outliers. But let's take some notes first. So let's say we have a number line. On the left side, this is going to be the minimum value, and on data, the minimum will be at 0 percentile, and the maximum is basically the 100th percentile. Now, Q1 is going to be the median of the lower half of the data. And Q3, that's how you can find the 3 quartiles. The interquartile range represents the middle 50% of the data. IQR is the difference between the 3rd quartile and the 1st quartile. And so that's how you find it. By the way, Q1 represents the 25th percentile, and Q3 represents the 75th percentile. Now let's talk about the outliers. Sometimes you may have a data point that is how this process works, like how we can go about it. So we have 5 and then 6 outliers. So let's go ahead and find the IQR value, and let's see if there's any outliers in this list. So what's our first? First, rewrite this. Now our next step is to determine if we have any outliers. So looking at the numbers in this list, do any one of these numbers stand out? So Q1 is 6, and the interquartile range is 9. Q3 is 15, and then it's going to be plus 1.5 times 9. 1.5 times 9, that's 13.5. So 6 minus 13.5 is negative 7.5. And then 15 plus 1.5 times 9, that's going to give us 28.5. Now an outlier will be any number in this list of numbers that is not in this range, or that is outside of that range. So is 26 outside of this range? 26 is in this range. So therefore, 26 is not an outlier. Now, let's say if this was 29, then it would be an outlier. Let's try another example. So let's say we have 50 numbers.
I know what you're thinking. Again, this guy eating my head. You see, I'm not gonna stop. I'm not gonna stop because you know why? I know exactly where you are because I was in your place. The place of scarcity, place of...
In this video, we're going to talk about how to make box and whisker plots. Now, what you need to be able to do is you need to be able to identify 5 key data points in your data set. The first 2 are very straightforward. It's the minimum and the maximum. Now, the other 3 data points, I can quartile things on a number line to the minimum and ascending order. And then is in the data set. It's going to be Q1, which is 12. My 1 is also between negative 12 and 52. So 49 is not an outlier. So now that we know we don't have any outliers, at this point we can draw the box plot, or the box and whisker plot. Let's begin by creating a number line. The lowest value is 8 and the highest is 49. So let's start from 0 and let's go by tens until we get up to 50. So first, let's plot Q1. Q1 is 12, which is approximately right there. And then Q3 is 28, which is just under 30. And then draw a rectangle. Now Q2 is 20, so we're going to put a line here. So as you can see, this is Q1, Q2, and Q3. Now our next step is to plot the minimum, which is around 8. So there it is. And then the maximum is at 49. So of course we had an up 34 in the column. So if you type in equal, this. In this video, we're going to go over the different shapes of a distribution. So the first one we're going to consider is a symmetric distribution.
This is right skewed. This is left skewed. So it's 10. This is 2 minutes.
Distribution. Now, why is this distribution symmetrical? If we draw a line right in the middle, notice that the left side is basically identical to the right side. And so that makes this distribution symmetrical. And right in the middle, we're going to have the mean. And this also represents the median, which is in capital M. Now on the x-axis, we basically have the values. On the y-axis of this graph represents the frequency of those values. So what do you think the mode is? with the highest is the number that appears most often in the list. Now let me give you an example of a unimodal graph. We have here, there's only one mode. This is bimodal because, as you can see, there's 2 modes. And this is trimodal because there's 3 peaks, there's 3 modes. You can also say that it's multimodal because it has many modes. Now let's go back to a symmetric distribution, but for a box plot. So this is Q1, the first quartile, this is Q2, and this is Q3, the third quartile. So this box plot, or this box and whisker plot, represents a symmetric distribution. Notice that the length of the first box on the left is the same as the length of the box on the right. So what this means is that Q3 minus Q2 is the same as Q2 minus Q1. So that represents a symmetric distribution. The second thing is the length of the whiskers. The whisker on the left is equal in length to the whisker on the right. So everything about this box plot is symmetrical. Now here's another distribution for you to consider. Would you say it's symmetrical, or would you say it's skewed to the right or skewed to the left? So notice that we have this tail of data on the right side. So therefore, the distribution is said to be skewed
to the right.
To the right. Some textbooks will refer to this as a positive skew. Now, where is the mean, the median, and the mode in this case? The mode is going to be somewhere over here. I mean, not the mode, the median. This is the median represented by capital M. Now, where is the mean relative to the median? So because the data is skewed to the right, the mean is going to be to the right of the median. So we can say that the mean is greater than the median. Now what about the mode? The mode occurs at the highest frequency, so basically at the top of this graph. So the mode would be right here. So notice that the mode is less than the median, or we can say that the median is greater than the mode. So in a unimodal distribution, the mean is going to be greater than the median, and the median will be greater than mode. Now let's talk about the shapes of the box plots for.
Do not use Microsoft Excel without ChatGPT and AI because you're wasting hours of your time without it.
A distribution that is skewed to the right. So here's one possibility. Notice that the length of the whiskers are the same, but the box on the right is longer than the box on the left. So, as we said before, this is Q1, Q2, and Q3. So Q3 minus Q2 is greater than Q2 minus Q1. In this case, the data is still skewed to the right. As you can see, the right box is longer than the bottom. Now, let's say if the boxes in the box plot are equal in length, but the whiskers are not. The data will still be skewed to the right in this case. So for this example, Q3 minus Q2 is equal to Q2 minus Q1. However, the whisker on the right is longer, and so the data will still be skewed to the right. Now sometimes you can have a combination of the two. So the box on the right will be longer than the box on the left, and at the same time, the whisker on the right could be longer than the whisker on the left. So this is another example in which the data is skewed to the right. Now let's talk about the third distribution that you need to be familiar with. So in this case, notice that the tail of data is on the left side. So therefore, we can say that this particular distribution is skewed to the left. Some textbooks will refer to this as a negative skew. The median, or to the right of the median, mean is less than the median. And as we know, the mode is going to be basically where the data is at its highest point. So the mode is the value with the highest frequency. So notice that the mode is to the right of the median this time. So the mode is greater than the median. So in summary, remember this. For a distribution that is skewed to the left, the mean is less than the median, which is less than the mode. Assume, of course, it's unimodal. Now let's talk about the box plots for this type of distribution. So let's say that the length of the whiskers are the same. So in this particular instance, Q1, or rather, let's say Q2 minus Q1 will be greater than Q3 minus Q2. Now the second type of box plot with a negative skew will look like this. Let's say if the two boxes are equal in length, that is Q3 minus Q2 is equal to Q2 minus Q1. If the whisker on the left is longer than the whisker on the right, then it also will be a distribution that is skewed to the left. And finally, we can have a combination of the two. The box to the left can be longer, as well as the whisker on the left. So that's another box plot that has a negative skew, or is skewed to the left. So that's basically it for this video. Hopefully you have a better understanding of skewness and the different types of distributions that you need to be familiar with. Thanks for watching. In this video, we're going to talk about how to calculate the sample mean and also the population mean. But first, we need to know what the difference is between the sample and the population. What would you say? What's the difference between the two? Let's draw a circle. And let's say this circle represents the population in city XYZ. So let's say this city has 100,000 people living in it. That's going to be the population, represented by capital N. All city names divided by the Greek letter mu, entire city, to do more work. The population considered N is the entire population. Ideally, we want the sample mean to be as close as possible to the population mean. And as we increase the sample size n, the sample mean will approach the population mean. So let's say if we increase the sample size from 100 to 1,000, we can get a better estimate of the population mean if we do that. But it's going to be 10 times more work to measure the weight of 1,000 people as opposed to 100. So there's a trade-off. If you want to get a more accurate answer, you need to do more work. Now there's something else that you need to know. What is this? The sample mean is referred to as a statistic. Now I'm sure you heard the word statistic. Like median, mode, these are statistics. They're basically measures of a sample. Now, the population mean is not considered a statistic, but is a different term that applies to it. The population mean is referred to as a parameter. Now you might not be used to hearing that one, but that's what it's referred to. It's a type of parameter. Now let's go over the formulas for a sample mean. The formula for the sample mean can also be represented this way, using sigma notation. So it's the sum of the data values, starting from the first data value and into the last one in the sample, divided by the number of data items in the sample. So this is equal to x1 plus x2 plus x3, and then this continues all the way to the last item in the sample, divided by n. Now for the population mean, the formula is very simple. The only difference is that we're not going to be using lowercase n, but we're going to be using capital N, which represents the size of the population. Lowercase n represents the size of the sample. So let's write that, sample size, and this is the population size. Now the rest of the formula will be very similar to what we have above. It's going to be x1 plus x2 plus x3 all the way to xn, but we're going to use capital N divided by capital N. And so now you know the formulas that correspond to the sample mean and the population mean. They're very simple. So that's basically it for this video. Thanks for watching.
So, True School of Music is very, very closely connected to the industry. Range of the best industry professionals who are specially mentoring TSM students. The point of this mentorship program is to bridge the gap between academia and industry. So the practical knowledge of the industry is coming into play into our curriculum through these mentorship programs. Whoever's interested in coming into the music industry, take a look at what we are doing. So you find your true calling and join True School of Music. We would love to have you as part of our family and welcome you to the music industry.
In this video, we're going to talk about how to calculate the mean of a group frequency table. So what we have here is the grades of students, and you can see the grade intervals of 40 to 49, 50 to 59, and so forth. 60 to 69 would be a D, 70 to 79 is a C, this is a B, that's an A. Anything less than a 60 it would be an F in most schools. The second column contains the frequency. So this tells us the number of students who scored in this range. For instance, there are 6 students who got a D on the exam. 8 students who had a score between 80 and 89. 4 of this cannot complete items in the set. It's gonna plus the upper boundary of the interval divided by 2. So in the grade interval of 40 to 49, the lower boundary will be 40, the upper boundary is 49 divided by 2. So we get 89 divided by 2, which is 44.5. So that's the midpoint for this interval. Now let's do the same for the next one. So the second interval, which is... Now our next step is to take the sum of the frequency column. So this will give us this particular value, which will help us to calculate the mean. So it's going to be 3 plus 5 plus 6 plus 9 plus 8 plus 7. So this tells us how many students are in the class. And so there's a total of 38 students in this class. Now the next thing we need to calculate is the sum of the frequency times the midpoint values. So we're okay, that line is not straight. So we're at 6,008 here. This one, which one? Notice that the highest frequency occurs here. The chances are the mean is going to be between 70 and 79, because most students scored in that range. I mean they had a C on the test. Can the mean 9 to 14, which gives us this? So we're going to call this cumulative frequency. We're going to start with this number 3, and then we're going to add 5 and 3 together, which will give us 8. Then we're going to take this number, add 6 to it, that's going to be 14. And then we're going to add 9 to 14, which gives us 23. And then 23 plus 8 is 31. And then 31 plus 7 is 38. So we get this number, because there are 38 students. And half of 38 is 19. So the middle number is basically the median. 19 is somewhere between 14 and 23. So after 14, we're going to be done with this interval. 23 is in this interval, between 70 and 79. That interval starts with the number 15 and it ends in 23. And so 20 is in that interval. So the median is somewhere between 70 and 79 as well. Now let's work on another example for the sake of practice. So here we have the weights of different students in a class. And what I want you to do is I want you to use this group data to calculate the mean and determine which interval contains the median and the mode. So go ahead and work on this example.
What's up, bro?
I went back to sleep.
So let's begin by calculating the...
Went back to sleep.
Oh,
What you doing here?
studying statistics.
Nice.
cumulative frequency. So this is going to be 6. 6 plus 8 is 14. And then 14 plus 12 is 26. 26 plus 7 is 33. And 33 plus 3 is 36. And if we basically take the sum of the frequency values, that should give us 36 as well, which we can put down here. Now let's determine the midpoint values. So it's going to be the upper boundary plus lower boundary divided by 2, or vice versa. So the upper boundary is 139, the lower boundary is 189. Take the sum of this column. So it's either going to be take 59, which end up being the interval. Now 7 to 14. You start with the next number and you stop here. Range of, now this range, or that interval, covers a range of 7 to, now, so 18 is in this interval, which means that the median is also located in this interval as well. In this video, I'm going to talk about how to calculate the standard deviation of a set of numbers. Quick and simple. So the first thing you want to do is calculate the mean. So x bar represents the mean of the sample. And the mean is basically the sum of the numbers divided by the size of the sample. So we're going to add up the 5 numbers that we have, 82 plus 93 plus 98 plus 89 plus 88. And since we have 5 numbers, we are going to divide this by 5. So 82 plus 93 plus 98 plus 89 plus 88. And that gives us a sum of 450. Now let's divide that by 5. 45 divided by 5 is 9. And if we add a 0, that gives us an average. The standard deviation is the mean. It's going to be plus sums and the mean.
Your American dream, now a reality with a 1-year STEM Master's. Graduate with a 3-year U.S. work visa and a high-paying job at the Big Four. Over 20,000 programs at 1,000 top American universities.
Let's talk about the mean absolute deviation. The mean absolute deviation measures the average distance of all the values from the mean. Now let's talk about how to calculate it. Let's say we have the numbers 7, 11, 14, 19, 22, and 29. Deviations. 4, and then this is 36 plus 6 divided by 5 minus. In this video, we're going to talk about how to about sending or true. Now, in both cases, the difference between 8 and 12 is 4. And 4 is
This is the best course I can say. It is perfectly fine. In just one course, in 6 months you...
In this video, we're going to talk about how to calculate the standard deviation of group data. So here we have a class of students, and in a table on the left side, we have different classes of grades. 50 to 59, we'll say that's an F. 60 to 69 is a D. This is a C, and so forth. And to the right of that, we'll say that it calculates the data values minus the mean values. And with this, we have the line right here. And so we're going to put the mean rounded value. The midpoint, 50, and 0.8, and standard deviation. That's how you can find it for this type of problem. Thanks for watching. In this lesson, we're going to talk about probability. So what is probability? For example, perhaps you've seen something like this, P of A. What does that mean? This is the probability of event A occurring. To calculate the probability of an event occurring, it's equal to the number of favorable outcomes, or outcomes that lead to event A occurring, divided by the total possible number of outcomes. Now, before we go over some examples that talk about how to calculate probability, we need to talk about something called sample space.